Hi, I'm Maciej, I'm a software engineer. In this video I will show you what is a short string optimization. So let's first recap what is a string object. Most high-level programming languages have a string type that allows to keep an arbitrary string, like hello world. The problem with this is that compilers like to assign a constant size to each type so that it's easier to manage things like structures or arrays. For example, if an integer is 4 bytes, it's always 4 bytes. It doesn't matter whether it has a value 5 or 500 or 5 million. If it's 8 bytes, it's always 8 bytes, and so on. It's just easier for the compiler. Interestingly, the same happens with strings. The compiler really wants all string objects to have the same size, which seems counterintuitive, because for us, programmers, strings can be shorter or longer. We can actually ask the compiler what it thinks about two different string objects in a program. As you can see in my example, two string objects, they have the same size, as far as the compiler is concerned. How is this possible? And how can we please both the compiler, who wants to see objects of the same size, and the programmer, who wants different objects to contain different data? The solution is simple. The actual data is only indirectly managed by the string object, like on this diagram. As you can see, the string object has a pointer to the data that can be of any length. It can be shorter or longer, but the string object, or what the compiler thinks of it, is always of the same size. On my system, it was 24 bytes. Most programming languages solve this problem in the same way, and it applies not only to strings, but to other data structures as well. But there is a problem with this approach, because every object which is constructed with this strategy involves a dynamic memory allocation, and it can have performance implications. There are two reasons for it. One reason is that the memory allocator has to be involved with every such object, and the other reason is that the cache doesn't like when we work with data that is not kept closely together. If the actual data, the string content, is very long and it takes a lot of time to obtain it, for example, it has to be loaded from some external system like a database or a network, then such a dynamic allocation with this additional memory block is not a problem, it's not a big deal. But what about strings that are very short, or that are easy to obtain, or that are already embedded in the program? Think about car plates, or phone numbers, or country codes, or perhaps error codes. There are many examples of very short strings that can be very easy to create, to obtain. And for such short strings, the additional memory allocation can be a potential performance issue. Fortunately, there is a way to avoid this allocation for an arbitrary limit of what we consider a short string. The solution is to reserve a small amount of space directly in the string object that will contain the string content if it's short enough. If it's longer than the reserved space, it can be managed indirectly in a separately allocated memory block. But if it's short enough, it can go directly into the object. Here is how it could look like for a possible length limit of 8 characters. There are 6 string objects on this diagram, but only 2 of them need to manage their content in a separately allocated memory blocks. All the others are short enough to be placed directly in the string objects. This is exactly how the short string optimization is supposed to work. So where is the catch? there is always some catch. And here we have potentially increased the size of the string object because we have placed a reserved space in every such object. Some of the space can be wasted if the string object is not using it. But this is exactly why the limit of what we consider a short string should be a configurable value, so that it can be tuned optimally for the given application. Think about implementing a custom string type with this optimization in mind, and check whether it makes sense in your particular application. I have implemented something like this in one of my projects, and it made a difference. It was worth the effort. I'm Maciej, I'm a software engineer. Write some good code and see you next time.